Hi guys, the quantitative variable our group have chosen is household size. So today, me, Susana, and Soleil will be analyzing the household normal distribution versus the actual data distribution.
What is the purpose of a normal model distribution? It is to determine the percentage of the values that are in the range of a given number of standard deviations from the mean. So as we can see from our values of the household numbers, we had a minimum of 3 and a maximum of 9. Our mean was 4.8125 and our standard deviation was 1.759498. Using these values, we made a normal model distribution graph. This value was the mean. This value was the mean plus 1 standard deviation. This one was the mean plus 2 standard deviations, and this was the mean plus 3 standard deviations. Then on this side, we did the exact same thing, but instead minusing the standard deviation values.
Actual data distribution. One standard deviation, we have gotten 56.25%. How did we get that? Let's move back to this model. So any student in our class has a household number that is greater but not equal to 3, but less than or equal to 6 will be within the 1 standard deviation, and that will be 9 students. 9 divided by 16, and that's the total number of students in our class, we will get 0.5625, and that will give us the answer 56.25%. 2 standard deviation, we have gotten 93.75%. So any student in our class with a household number that is greater but not equal to 1, but less than or equal to 8 will be within the 2 standard deviation, and that will be 15 students. 15 divided by 16, we will get 0.9375, which gives us the answer 93.75%. 3 standard deviation, we have gotten 100%. So any student with a household number that is greater than negative 0.4660, but less than or equal to 10 people in the family. So that will be everyone, because we all know you can't get a negative amount of people within a family, so it's basically saying that any student with a household number that is less than or equal to 10, and that will be everyone. So 16 over 16, then we will get 100%.
The normal model shows that the expected percentage between 3.053 to 6.752 should be 68%, but according to the actual data distribution, it is around 56.25%. The normal model also shows that the expected percentage between 1.2935 to 8.3315 should be 95%, but according to the actual data distribution, it is around 93.75%. The normal model shows that the expected percentage between negative 0.4660 to 10.091 should be 99.7%, but according to the actual data distribution, it is 100%. And our data is unimodel. For the most part, we think that the normal model distribution fits our actual data distribution well.